Today I will discuss an experiment modulus of rigidity by static method. You know modulus of rigidity is shear stress upon shear strain based on Hooke's law, right? So here there is a iron rod whose modulus of rigidity is to be determined. Okay, the rod is fixed at one end and there is another end, there is a pulley. If we increase the load in one side, there will be an angular twist. You will see there is an angular twist. So first of all we have to calculate the circumference of the pulley with this copper wire. There is a wire. We have to calculate the circumference of the pulley using this copper wire, and then we have to calculate the length of the wire by measuring tape. Then that is the circumference of the pulley. So from the circumference we have to calculate the radius of the pulley by using the formula. Okay. Then we have to take a screw gauge. So before first we have to calculate the least count of the screw gauge. You know the least count, the number of circular scale division and the least pitch of the screw. Then you calculate the least count of a screw gauge. Using that screw gauge we have to calculate the radius of the rod. We have to place the screw gauge in such a way like this, okay, and then we have to take the main scale reading and the corresponding circular scale reading. Okay, we have to place a screw gauge in a particular place in a horizontal direction and as well as the perpendicular direction like this. First we have to take in horizontal direction and then we have to take the vertical direction reading. Okay, like that we have to take another more two observations. The first one at the first of the rod, second one at the middle portion of the rod, and third one at the end portion of the rod. Then we have to calculate the mean radius of the rod. Okay, using the screw gauge we have to calculate the radius of the rod. Now the next part of the experiment, there is a two pointer in the scale. Okay, this is pointer number 1, that is called theta 1, and pointer number 2 is called theta 1 prime. Okay, and one scale is there in the rod. There is a scale is there. So from the scale we have to calculate the distance between these two pointers. Suppose we have to fix the distance between two pointers is say 20 centimeter. Okay, 20 centimeter we have to fix the pointer. Suppose we have to fix the first pointer at 10 and the second pointer at 30, then the difference will be 20 centimeter. Now it is already 20 centimeter is fixed. Now fixed the pointer of the scale in the 0 0 position. See, both the pointer is the showing result in 0 0. Now and in the hanger no load is there. See, in the hanger there is no load is there, only hanger is there. The consider the zero load means deflection also 0. Now there is some different load is there. We have to take a load one by one and very gently we have to increase the load in the hanger. Now what happened when you increase the load, there will be some deflection is there. If we increase the more number of loads, the deflection will be more. See, if we increase the load one by one, there will be some deflection in the scale. Okay, see, there is a deflection in the first pointer is the maximum and the second pointer is the deflection is the minimum. So we have to note down the deflection from the scale. Okay, up to 3 kg we have to increase the load one by one. Every load is 500 grams. So one by one you increase the load 500, 1, 1.5, 2 kg like that. Up to 3 kg you have to increasing the load, and then again you release the load like this. You release the load one by one. Again from 3 to 0 you will decrease the load, and when you decreasing all the load, again the pointer come back to its previous position like 0. So when you increasing the load and decreasing the load, then you take the difference of the load and calculate the mean deflection. Now you plot a graph, mass along x-axis and the angular twist or the deflection in the y-axis. It will be a straight line based on the Hooke's law passing through the origin. Okay, we have to draw a best fitted graph. Okay, and then you calculate the slope from the graph. Using that slope and the formula modulus of rigidity eta is 180 dlg by pi square r to the power 4. Now L is the length of the rod between these T point, and now we have to fix at 20 centimeters. So L should be 20 and D is the diameter of the pulley. Already we have measured diameter of the pulley, and G is the acceleration due to gravity, and R is the radius of the rod we have taken by vernier caliper. Sorry, you have taken by screw gauge. Already you have taken. So using the formula and the slope, you will calculate the modulus of rigidity of the material. Now the material is iron. Okay, its value should be like within 3 to 8 into 10 to the power 10 Newton per meter square. Okay.